Hello and welcome to fourth lecture of the fourth chapter of our comprehensive course on machine learning, data science, and artificial intelligence. Here we were discussing actually this thing that is core features of Numpy. We discussed this broadcasting and everything and how for loop is not required. Now here one more core feature of NumPy is that it provides extensive mathematical functions. So not only functions of algebra, statistics, Fourier transformation, trigonometry, calculus, anything in maths, and you can easily do that by NumPy. And you don't have to even know mathematics in much depth. You have to know some little bit of programming, and just in one or two lines of code, you can achieve the functionality which would require very lengthy calculation otherwise. Then integration with databases. That is also very important because ultimately we want to use it for data science. So it is excellent tool for fetching data from large data sets and transforming them. Okay. And large it can handle, so small also obviously it can handle, and various different types of data sets like SQL and Excel and many different types of data set it can handle. Then input output capability. So it allows data scientists to import data from external sources like CSV file, which is almost similar to Excel file format. An Excel spreadsheet can be saved as a CSV and text file and any other format, and then big data of various big data formats, HDFS, any format NumPy can easily import. It is now what is its importance? That was its general importance or important features. But what is its importance in data science? Then this is the most important thing, that it is a foundation for other libraries. For example, earlier we had seen this thing that the scikit-learn can practically handle everything in data science. So just one library and it will handle everything. But even with scikit-learn, you will require NumPy, pandas, and maybe matplotlib and seaborn, or at least matplotlib. So NumPy, without NumPy, you cannot do the data science. So, okay. Then one more thing is there where it is. Sorry, where were we? Okay, here. Then any machine learning library such as scikit-learn and TensorFlow or pandas or matplotlib, but with them NumPy will be required. The functions provided by NumPy makes these libraries efficient and easy to use. Performance wise, NumPy is very fast because we have seen that internally C++ and Fortran routines are used. So that is why it is very fast and compared to loops. Versatility in data handling, it can handle images, sound data, numerical data, or any other form of data. Then educational value. NumPy is not only for data scientists but even for Python programming education or data science education. It is an excellent beginner's library because we have also started our course practically. Earlier chapters were about programming, but starting from this chapter we have started libraries, and very first library which we introduced was NumPy. Okay, then it can handle maths and statistics easily, and again I will show that diagram, that is the interdisciplinary nature of data science. So maths will be required for data science. Community is very vibrant and helpful people in NumPy, since it is from 2005. Therefore, the community is very large, and you will get the answer of your queries almost immediately. Ecosystem is also very robust, and newer and newer versions of NumPy are always coming. So as Python actually was 2, then 2.8, and then 3, 3.1, 3.2, nowadays 3.13. So as Python gets upgraded, NumPy also is getting upgraded quickly. Okay. Then, so NumPy is not just library for numerical computation, but it is a fundamental tool for every data scientist. And because of its computing capability, performance, ecosystem, it is an indispensable tool for machine learning, data science, and scientific computing. Okay. Now let us see this part. Creating and manipulating NumPy arrays. Originally, earlier we have seen this, that this is called a one-dimensional array. It has one axis only, and as indexing in Python starts from 0, we will call it 0th axis. So axis 0. Then here, two-dimensional array. Here the shape of the one-dimensional array is written like this, 4 comma. So after comma nothing is written. 4 means it has 4 elements, and after comma nothing is written. So 0. And why it is written 4 comma and not comma 4? That also we will see. Okay. And then this two-dimensional array. So this is 0th axis. So that means that internally this will be stored in 4 columns. Okay. So 0th axis, this is 0th axis, like that. And this is first axis. So that means two-dimensional array, and its shape is called 2, 3. It has 2 rows and 3 columns. So that means this is the number of columns. Okay. Then this is a three-dimensional array. It has first zeroth axis, which is height, first axis, which is its length, and second axis, which is its breadth. You can see that the height wise it has 4 rows, length wise it has 3 columns, and depth wise it is having 2 depth. So that 432, that is the shape of this array. Okay. So you must be able to write the shape of NumPy array, or rather reverse. When shape of NumPy array is given, you should be able to visualize that this array is like this array is like this, and this array is like this. As such, any higher dimension is possible. That is 4 dimension, or 5 dimension, or 6 dimension. But beyond 3D, the visualization is difficult. Now in next lecture, we will start with this, creating some simple NumPy arrays. Okay. And at that time, initially, I will show that suppose a new learner, completely new learner, does not know the command and what the command does, then also he can easily get that from Jupyter. Okay. So we will start next lecture, this thing in next lecture. Thank you.